Hey there, Earth Science fans, it's Mr. Cole here. And have you guys ever noticed how the sound of a car changes when it approaches you versus when it drives away? It's kind of like this. Vroom, vroom. As it approaches you, the sound gets higher, and as it drives away, the sound gets lower. Well, this change in sound is called a Doppler effect. And as the car drives towards you, the sound waves get pushed together and shorter, and so the sound frequency gets higher or higher pitched. And as the car drives away from you, the sound waves stretch out, and so the sound gets lower. All right, we'll come back to that example in just a second, but at this point we'll talk about how in 1929 there was an astronomer named Edwin Hubble, and he discovered that most distant galaxies are red. That's right, he looked through the telescope and found that most galaxies have a light red or kind of pinkish tint to them. And what that told him was that most of those galaxies were moving away. So we talked about the Doppler shift in sound. Well, it happens with light too. If a star is moving away from Earth, the light gets stretched out and turns red. If a star is moving towards Earth, the light gets pushed together and the waves get shorter and it turns blue. Now this is connected to what we learned about in the electromagnetic spectrum. If a visible light wave gets shorter or decreasing, it gets shifted towards the blue end. Or if it gets longer or increasing, it gets shifted towards the red end. So just to recap, that Doppler shift, or the change in sound of a car as it approaches you versus when it drives away, also happens with light. When light travels away from Earth, it gets stretched out and turned red, and when it travels towards Earth, it gets pushed together and turned blue. So therefore, not all galaxies are going to be red. The ones that are traveling towards our galaxy are going to be blue shifted, like Andromeda, which is on a collision course with the Milky Way in about 4 billion years. All right, so going over the main evidence for the Big Bang again, the first was redshift, which we talked about, how light from distant galaxies turns red, which means most of the galaxies that we see in the sky, if we look through a powerful telescope, they're going to look red. And that means that they're moving away from Earth, which points to the fact that the universe is expanding and started with this rapid expansion 13.8 billion years ago. Furthermore, we can track the speed at which those galaxies are expanding, and that's where they got that number, 13.8 billion years, based on how fast the galaxies are traveling. They can basically rewind the clock and figure out that it must have started expanding about 13.8 billion years ago. The electromagnetic spectrum provides evidence of this. As the light waves increase, they turn towards the red end of the spectrum, which is why those galaxies turn red when they move away. And if the wavelength gets shorter, they get shifted more towards the blue end, so those galaxies that are moving towards Earth are going to appear blue. And the second major evidence for the Big Bang is this thing called cosmic background radiation. What that is leftover energy from the Big Bang that we can detect. We can pick it up on our satellite dishes. You guys are probably too young to remember listening to the radio, but if you ever have listened to the radio, you know in between stations on the radio, they're static. It's kind of like, it's not a clear signal. It's called radio static. Well, radio static is cosmic background radiation. It's all this energy that's raining down throughout the universe, all over the Earth and everywhere, all the time. It's just, it's raining. It's raining radiation all the time. And our satellite dishes pick it up, and it sounds kind of crinkly like static. Well, the only reason that there would be all of this leftover energy raining down everywhere in the universe is if there was some huge energetic event like the Big Bang that sent energy throughout the universe all the time. So the two main pieces of evidence we talk about today, the red shift, galaxies are red and moving away from Earth, showing that the universe is expanding. And second is cosmic background radiation, all this leftover energy from the Big Bang that we can detect everywhere all the time. All right, that's it for me, guys. I'll see you next time.